all the respected delegates from India and Republic of French. Namaskar. And special welcome to the French team because you are our guest and we believe in Atiti Devo Bhava. Guest is our God. I am thankful to Dr. Chembalu, who is the organizer, and Dr. Camden Benoit for inviting me to present my work on very crucial water body that we call spring, which is basically the lifeline of Himalayan people. So I will talk about, I will show my experience which I gained in last 4 or 5 years, extensively working from JNK to Arunachal Pradesh. So that is presentation is based on my experience and my research. So my topic is role of Springshed management in sustaining the river's present status and initiative in India. I am from NIH. NIH is basically, it was incepted as a project of Roorkee University. Now it is IIT Roorkee in 1978. But later on, Ministry of Jal Shakti took over it. And now it is R&D Institute under Ministry of Jal Shakti, Government of India. So before going to this presentation, I just throw one question before you. The Himalayas water tower or water stress? It is very interesting because last month in June, I visited my native place that is very close to Yamunotri, that is the origin of Yamuna river. And if I faced such type of problem, I stand in a queue. You can see me at here to catch a 5-liter cane, and it just took more than 1.5 hours. So this is basically the real situation when we talk about the water tower or third pole on the earth. And as per ICI mode, 8 out of 10 mountain people don't have it in their homes. They have plenty of water, but they don't have it in their homes. And as per WHO data, World Health Organization, 5.5 crore hours of time every day was spent in collection of water for household needs, primarily by the women, because women and children, they are supposed to collect the water in the mountain area of country. So you can see that this much amount of hours, amount of time they spend every day to fetch a headload of water. So you can imagine that how they will fulfill their dreams if they are spending a lot of time to just collect the water. So if you look this GRACE experiment, gravity recovery experiment, gravity recovery and climate change experiment that done by NASA, they have conducted this experiment among 37 largest ecosystem in the world. And you believe that this Indus Basin, which is bread and basket of India and Pakistan, that is the second largest overstressed ecosystem in the world. So, and it is the water level is declining by 4 to 6 mm per year. And if you look Tavi River, where my dear friend Chembalu is working, you can hardly find any water in the lean seasons. And this is the lifeline of 20% population of JNK. So in such situation, you can imagine. But another figure I would like to see you, that this is, you can see that a slurry type of water is coming from the ground. This is a picture which last year in January 2023 was very popular in media. That is called Josimat subsidence. Being as a government of India, I investigated that case, and because there is lot of rumors that this water is coming from the NTPC tunnel. So, and there is lot of subsidence after coming this groundwater. So all these events force us to think about what is actually going in the mountainous area. So if you look, that glacier and springs are the basic source of all water in the mountainous area. There is hardly, and these, after joining accumulated flow of several springs, they make a small stream, that first order stream or maybe second order stream, and sometimes we call nala or gadhera in our local language. And these small stream made rivers, and after that these rivers can be utilized to build a dam. And last 70 years of freedom, we have made lot of dam, lot of canals. We have built lot of resources. But did not think about the source, where water will come in these reservoirs, in these streams. Because now there is a paradigm shift in our government schemes. We are thinking about to source sustainability, and there is lot of if you look our government of India scheme, Jal Jeevan Mission, source sustainability is major component. In PM KSY WDC, spring is a major activity in watershed programs, and even this groundwater estimation committee CGW, they are trying to measure some springs so that the spring discharge can be incorporated in the groundwater estimation committee. So spring is basically the points where invisible groundwater become visible in the form of spring. If you might recall the theme of World Water Day 2022, groundwater making invisible visible. So springs are the true example that is because springs are the point where invisible groundwater become visible. So that themes are very relevant to the springs, and it is the sole source of water in the Himalayan area because these rivers and other water sources, they have locational disadvantage because they are flowing in the deep gorges. So it is not possible to lift the water. So as per Niti Aayog, about 15% population of the country depend upon the spring water, and there is hardly any river in the world which is not fed by the spring. So if you look this table, that is one of our NIH study, that if you look that the glacier contribution at snout of Gangotri Glacier, which is one of the largest glacier in the world, that is around 97%. Entire water is from glacier, and there is less contribution from the runoff supply. But when we go to downstream side, the glacier contribution is declining, and spring subsurface contribution is increasing. And Deprayag, where this Bhagirathi and Alaknanda become Ganga river, at there the snow glacier contribution is only 25%, and the subsurface or the spring contribution is around 56%. And if you look the last year report of this Central Groundwater Board, if you will consider this total annual groundwater recharge, that is 1.11 BCM for Himachal Pradesh state. Out of that, 0.13 BCM is only spring. So there is need to look in this on these water sources, and these four are the major region where these springs are very frequently occurred. And fortunately, this is a great confidence that these regions are among the 36 biodiversity hotspot of the world. So these springs also not only quench the thirst of the local people, even maintain the base flow of maintain the biodiversity of that particular region. But in last 2 or 3 decades, these springs are dying at an alarming rate. And as per Niti Aayog report, which was released in 2018, half of the perennial springs have already dried up or become seasonal, resulting into acute shortage of water, drinking and other domestic purposes across tens of thousands of mountains. So, lot of villages have migrated due to the water, because wherever people moves, wherever water moves. So, if you want to sustain the water supply in Himalayan area, there is a need of systematic, coordinated spring set management approach, which will be useful to improve the accessibility of water, as well as to achieve the United Nations Sustainable Goal, not only 6, that is particularly for clean water and sanitation, even this no poverty, SDG 2, zero hunger, SDG 5, gender equality, SDG 15, life on land. So if you want to achieve these goals, we have to address the issues related to the drying of springs in the mountainous areas of the country. But unfortunately, when we start in last 6 years, we start this program. So working on spring is just like a Jones weather forecast. It is very jockey type joke that in this Jones weather forecasting stone, they just hang a stone, and if it is a stone is wet, it is a rainy. If it is a dry, not rainy. If it is a shed on ground, there is a sunny. So same type of situation is in the case of springs when you are working in the spring. And yesterday, Dr. Professor Datta has rightly said that in our country, scarcity of data is a major challenge or major limitation or major constraints in the field of hydrology. So you can't manage what you can't measure. If we don't have a data, how we can make a DPR or plan or project? It is very impossible. So, and this NITI Aayog report also highlighted there is a need of creation of web-enabled database, web portal on which the springs can be mapped, so that we have a common platform and all the state government or all the implementing agency can share their data. This will be helpful to understand the present status of the springs in this specific time, because if we don't have data, we cannot say that how much springs have been dried up or how much a spring has been declined. And local springs can be protected during expansion of development, because nowadays, due to this expansion activities, if you look in Nepal, as per one of the paper last year published in a journal, that the major reason for drying of springs is cutting of roads and tunnels. So, if you know the location of springs, if we have data on the springs, so when we formulate some development plan, these springs could be in the mind that we should not do so that their recharge area or that springs can be hampered due to the development activity. And funds and priorities can be decided, because if we know that this Himachal Pradesh has more vulnerable springs as compared to Uttarakhand, then more funds can be given to the Himachal Pradesh or J&K. Okay. And based document to assess the impact of Springshed. There is lot of Springshed program nowadays going. Dr. Professor Datta know, because he is one of the expert in NMHS. Lot of programs, but if we don't have base document, pre-project data, then how we can say that this is the actual impact of the that project? So it will, if you have a spring inventory, then we can say that this is the impact of the project. So NIH has started a couple of projects in different part of the country, in J&K, in Himachal Pradesh, in Western Ghat, in Jammu and Kashmir, and we have formulated a methodology that I call cubic meter approach. That is MMM. We have to motivate the people that we can revive their springs, and then Government of India must be launch some spring rejuvenation program in different blocks or different tehsil, so that we can develop some package and practices in different agroclimatic region of India. And then finally this developed package and practice can be transferred to the state government or the stakeholder, so that, and then the role of us is to monitor the performance of the stakeholder of state implementing agency. And this cubic meter approach is based on 6-step method, that is spring mapping. We have to map all the springs. Then based on mapping of that springs, we have to identify the vulnerable springs, because we cannot, because there are, as per NITI Aayog, there is a 3 to 5 million springs in the country. We cannot recharge or revive each and every springs. So we have to identify the vulnerable springs, which is very vulnerable, which is very important, which have high social importance. And then we have to monitor these vulnerable springs, create some database, and we have to identify the recharge area of springs head, so that we can develop some adaptive measures to increase, to augment the discharge of that springs. And finally, we have to create some citizen scientists. We call it spring pehari, because I have already told that we cannot revive each and every springs. So these are some activities in Jammu, Kashmir and Himachal Pradesh. And based on that activity, we have created 2 web GIS based portal that we call Ishwar. Ishwar means God, because these springs are considered as abode of God. So I have given the name as Ishwar Information System of Himalayan Springs for vulnerability assessment and rejuvenations. And we have given a criteria to identify the vulnerable spring based upon the 8 parameters, so that we can identify that which spring is vulnerable in this particular area. And for giving weight of these 8 parameters, we have surveyed, we have interviewed different experts from the spring who are actually working on the spring domain, and we have given the different weight that, like spring discharge availability across the year is a major dominant factors which makes a spring vulnerable. So likewise, we have identified vulnerable spring in 2 different catchment. Like first one is Tavi catchment in Himachal Pradesh, and another is this Tavi catchment from Jammu Kashmir, and second one is Ravi catchment from Himachal Pradesh, and if you'll see that in total 981 springs, out of 981 springs, 471 only 23% springs in Ravi catchment are vulnerable, and in Tavi catchment only 10% springs are vulnerable. It means Ravi river springs are highly vulnerable than Tavi river springs. So such kind of calculation or such type of estimation is very, very helpful for the policy maker, so that they can first focus on these 23% springs of Ravi river catchment and 10% springs of Tavi river catchment. So, and we have to develop how to identify the spring set or recharge, because there is a lot of confusion between water set and spring set. So we have given a definition that spring set is basically, spring is just not a hole in the earth. It is basically a system where it integrates recharge area, transition zone, that is aquifer basically, and spring outlet. So and these three parts of this system is geographically located at a distance. It is not located at same place. It is located at distance, and that's why spring set is little bit complicated to the water set, because in water set we just consider on the topography of the area, but in spring set we consider the geohydrology as well as topography of that particular area. So for that we have to go some geological mapping, what kind of dip or strike in that particular area, so that we can understand the movement of groundwater flow in that particular area. And with the help of this observed spring flow data, flow data is very, very important in spring hydrology, because it is basically the result of all the process which is going on the surface and beneath the surfaces. So spring hydrograph gives a lot of information about the aquifer property, like porosity, what kind of porosity of aquifer, what kind of transmissivity of aquifer. So based upon that, we can categorize the spring in different category. That it will tell us that which springs is good for the recharge. You cannot recharge every spring, because if there is no storage, if the storage capacity of the aquifer which is actually feeding the spring is quite low, then how we can recharge that spring. And second one is, which springs can be reliable source of water supply for the local people. With the help of these spring hydrograph, we can identify that these are the springs which are the reliable source of water supply. And isotope, nowadays isotope is very, very important in this spring hydrology, because it tells about the source of water, spring water. Especially in Josmat case, there was a lot of the system was very complicated, but based on the isotope techniques we could identify the source of the gushing water which comes in the night of 2nd January, and we can distinguish spring that water from the water coming from the Antipsi tunnel. And second, this isotope is very helpful to identify the recharge altitude, because generally we assume that all the area upstream of spring outlet is it's recharge area, but that is actually not right. So this isotope techniques help us to identify the altitude of the recharge area, and with the help of this isotope technique, we can identify the mean residence times of particular springs. And you can see, and if you see that in this particular spring, there is a less variability in the isotope of different months. But in this particular spring, there is a lot of variability in isotope values of different months. So you can see that this particular spring has residence time 12 months, because if there is a less variability in the isotope of spring, it shows that there is the reservoir size is quite high, which is due to which the effect of local rainfall is not coming. So with the help of this, we can identify the mean residence time, and with the help of chemistry, we can identify because spring water it takes the property of the rocks which is in aquifer system. So with the help of, you can see in Katra town, the springs which is upstream of Katra town, they have different water quality, and the springs which is downstream of Katra town, they have different water quality. So this type of analysis is very, very helpful to identify the recharge area or source. This is also this Piper diagram or Gibbs diagram. There are a lot of diagrams which are helpful to identify what kind of weathering is in the recharge area and what kind of rocks is in the recharge area. So, with based on these studies, Government of India last year have started to first spring census of the country. I will just show a video. I prepared a small video because that last year this all work was acknowledged in the COP28, United Nations COP28, and one we have conducted one event at Dubai last year. So I will just show that.
There is a natural filter emerging under groundwater in mountainous valleys where the once invisible water transforms into a visible stream, gracefully flowing onto the earth's surface. Local people traditionally collect this floating water by constructing structures of various shapes, such as the mouth of a car or lion. In some places, they use plastic or GI pipes, leaves, through which the accumulated water flows to the ground. Through these conduits, or we can say channels, the gathered water delicately cascades to the ground, not only quenching the thirst of mountain dwellers, but also symbolizing resilience in the face of life's challenges. These mountain springs will get fresh and crystal clear water, and then they grow the small streams, rivulets, and eventually mighty rivers like Ganga and Yamuna. Actually, every river worldwide owes sustenance to these humble springs. The pristine quality of the spring water is said that mountain communities have a tradition of directly bringing from these sources. In the Himalayan region, where rivers course through deep gorges, transporting water to villages which are situated on the ridges is impractical. Therefore, the proximity of the springs became a fundamental criteria for settlement in these challenging terrains. In ancient times, these springs were regarded as abodes of the divine, and temples and statues of deities were placed nearby to discourage any encroachment and pollution. However, with the advent of piped water supply, these traditions faded, and the springs began to dry up. Unfortunately, the realization that these springs are the very source of water flowing through pipes and rivers was forgotten. It is only now, in the face of immense scarcity, that people are reawakening to the significance of these springs, recognizing that the water role, meteor island, known as the think tank of India, formed a working group in 2017, dedicated to the inventory and revival of the springs in the Himalayas for water security. The working group's report highlighted the indispensable role of the springs in providing water security to around 5 crore people in the Indian Himalayan region and a staggering 20 crore people across the entire nation. Surprisingly, the report revealed that the available data on the number of springs vastly underestimate the actual count, with only 3,000 and 12% of villages in Uttarakhand and Himachal Pradesh respectively officially recognized as the springs, whereas on the contrary, in reality, at least one spring is found in every one of these states. Therefore, meteor island emphasis on a web-based inventory of all the springs in the Indian Himalayan region, so that a concrete initiative could be taken for their regeneration by providing a basic database on the springs. In view of the recommendations of meteor island, the National Institute of Hydrology Roorkee, a research and development organization under the Ministry of Jal Shakti, developed their GIS grid portal named as the Information System of Himalayan Spring for Environmental Assessment and Regeneration, acronym the ISHWAR, for the Rabi River Catchment of Himachal Pradesh and the Kali River Catchment of Jammu and Kashmir, under the National Hydrology Project and National Mission on Environmental Studies, respectively. The program facilitates the data of about 1,500 springs on more than 30 critical parameters accessible with JET data templates. In 2022, the Ministry of Jal Shakti, Government of India, constituted a steering committee of banking experts to initiate and monitor the systematic mapping, a geothermal springs across the mountainous regions of the country and develop evaluation mechanism among various stakeholders to expedite Springshed management efforts in India. The committee, through stakeholders meeting and brainstorming workshops, gained an understanding of the tools and techniques employed by agencies working in the field of Springshed management in the country. The committee compiled information over 38,000 geotech springs in India and identified potential districts for spring occurrence. Consequently, the Ministry of Jal Shakti Government of India initiated the first spring census of the country in August 2022. To save time and avoid many relevant data acquisition, the census will be carried out using the Meghalaya. This acts as a catalyst for geodiversity photograph, customize information, and conduct mapping work in remote areas where mobile network is not available. The steering committee will also develop a resource book as well as modules on Springshed management to assist implementing agencies that encourage research on spring hydrology and hydrogeology in the country. The Ministry of Jal Shakti remains committed to build capacity among stakeholders through ongoing awareness programs. In line with the core value of Vasudev Kutumbakam, which means the world is one family. The Honorable Prime Minister of India has also called for Springshed management in the hilly region for climate resilient future. So, let us unite to conserve these water sources, nurturing a prosperous and water-rich world.
Climate change is still same for I don't believe in that. It's not going to be the
Thank you very much. This is all about my presentation.
Long live India and France friendship.